Welcome to the Masters of Engineering podcast. Cool products, the people who develop them, and how they do it. I'm your host, John Hirschtick. I've spent my entire life building CAD and PDM software, but the best part of my job is I get to meet some of the coolest, most innovative product developers on the planet. And in my podcast, you get to meet them too. Now, my guest today, Tony White, he's the Director of Innovation for Forever Oceans, which is based in Hawaii and worldwide. They are developing a way, they've developed a way to raise fish that we eat in a really cool way. It's like better fish developed in a better way. It's better for the planet, better for everyone. I'm looking forward to learning more. Tony, welcome to the podcast.
Hi, thanks for having me.
Thanks for being here. And you're talking to us from Hawaii, is that right?
Yep, I'm currently in Hawaii. This is where our research and development technology organization is based.
And I understand you travel a lot.
Yep, mainly to Panama, where on the west coast there we have our large farm that's in production. And hopefully in the future I'll get to travel to some of our own other locations around the world, Indonesia and Brazil.
And so let me start. Can you give us an overview of what you're doing at Forever Oceans, and why develop a new way to raise fish?
Sure. Well, just for context, fish farming is really big in the rest of the world. We don't see it a lot along the coast of the U.S. Due to regulations and a lot of different factors. But internationally, when it's done, it's usually done very close to shore or in fjords in Norway or Chile, off of China. And raising that many fish in a shallow water environment with not a lot of water flow, stagnation can lead to horrible environmental problems. So starting almost over a decade ago, different companies started researching how to move production farther offshore and what kind of benefits we might see from that. So Forever Oceans, we farm fish very far offshore, 5-10 miles. And when you're out that far, the water's a lot deeper, the currents are stronger. So any impact the fish might have in terms of waste is spread on a larger area. And the currents, it's kind of like the fish are on a treadmill there. They're always exercising. They have more water coming through the pen. So,
how long does it typically take a fish to grow? And how long with your...
It obviously depends on the species. I'm not a biologist, so I might make some mistakes here. But the Kampachi that we farm, it is ready for harvest in about 6 to 8 months. In the wild, to reach a comparable size would take 3 to 4 years.
Wow. So 6 to 8 months to grow to a harvesting size. So I've just learned one of my first, I'm sure it's going to be many interesting things. So you have a speed aspect here. And I knew that there was a big environmental component to what you're doing. You say that the way fish are farmed now create waste because of the location.
The location
is concentrated.
Mm-hmm.
So you don't create less waste. You just, or maybe you do, but the key idea is it's spread out in a place where it's not a problem. It's not so concentrated.
That's part of it for sure. From a waste perspective, we use technology to monitor our fish in real time when we're feeding. So we have a internal website. Our operators can run the fish farm automation from push feed, watch the feed leave the hopper and go into the water, watch the fish react. And the moment the fish start being not interested, we can cut off the feed flow. So while some farms might waste 2 to 3 to 5% of their feed, just missing the fish with it, we try to keep that at zero or less, not much more.
Oh, so you're able to optimize the feeding, and you watch the fish on camera.
Mm-hmm. Yeah, I mean, it's easy when you're farming terrestrial species, I'd imagine, but it can be kind of challenging when you're underwater. So you're talking about feeding hundreds of thousands of fish at once.
Was there one signature benefit that you said, this is what's driving us, or was it kind of like you knew there were a lot of benefits?
I think it's a combination of a lot of different benefits. We see the world population's growing. We need a sustainable source of protein, and producing protein and fish, at larger scale. We don't have to use any fresh water, and we can grow with a minimal impact. We had a Nature Conservancy report recently that shows we're creating less carbon per kilogram of fish than salmon or many other things. It's orders, 2 to 3 times better than terrestrial agriculture.
Oh, 2 to 3 times better.
Yeah, so we look at the feed conversion ratio. That's like a pound of feed to make a pound of meat. And that'd be a 1, that'd be a perfect ratio. Things like chickens and beef can be in the 10s to 20 to 30 range. With fish, we're approaching 1.5.
Wow. And that's much better than any other way to grow fish today.
As far as we can tell, a lot of the industry is moving towards RAS, recirculating aquaculture systems on land. And some of our hatcheries, use some of those technologies, but to farm the whole grow out in a tank takes an incredible amount of electricity to pump the water, keep it filtered, keep it oxygenated.
Sure.
So it doesn't have any impact on the ocean other than all the energy you're using and maybe the ocean water you're borrowing and the effluent you might create.
So you don't need any continuous energy supply to the farm site? You don't have do you have solar panels or something on the surface? No?
No. We do have, energy, diesel generators and solar that we use to run the feeding systems, but those don't run 24/7. The large benefit of our systems offshore is that they use single point moorings. So they weather vane. They'll pivot across and always have current moving the same direction through the pen from the front to the back. And that breaks a common parasite life cycle because they can't swim against the current. So as a result, we don't really have to treat nearly as much as many other farmers to keep our fish free of parasites.
So other farms are fixed and currents will
typically use a grid mooring. Mm-hmm.
Oh, okay. So you anchor it just with one point.
One single point.
Yeah. And how is it anchored? Is it with literally an anchor or?
Yeah, so we have an ocean engineering section of our team that designs our moorings, and usually it's a combination of one or more anchors and the right amount of rope and chain, depending on the depth and location.
I think you say on the website and other materials I looked at that you watch the fish you monitor the group fish behavior.
Yeah, so we're making a lot of recordings, and in the world we live in today with AI and machine vision models, using those recordings to detect stress or divers or different behaviors is definitely something we're looking at.
And you can detect stress, what do you're looking at fish and you're watching. What would you do about the stress, and what would it mean?
It could mean a variety of things. Many times we may not have mitigative strategies other than maybe to bring more oxygen, but the fish will move faster, and they're like a paparazzi. The Kenpachi we farm is very aggressive, very eager predator, and so when you're a diver just outside the pen, they'll all push up against the net and want to get to you, and if you're in the pen, they surround you. You can't see where you're going. Oh,
really?
Yeah. So and in terms of other machine learning things we do with our cameras, we also can measure the fish. Normally in traditional aquaculture, you'll try to take a sample, take a weight, see how the fish are growing, but 20 fish out of 300,000 isn't going to give you a great idea statistically. So we can get many thousands of measurements per day by measuring the fish with our stereoscopic cameras.
Oh, that is really, really, really cool, actually, to think about monitoring. And with AI, more and more automated, and you also get real-time feedback too. So do you ever look at, is it possible to say, hey, we altered timing or delivery of feed or some other aspect of it, and see in real time over a day, 2, 3, something happened in fish growth or behavior?
Yeah, I think the main sensor data we look at, kind of the pulse of the fish cohort, is the dissolved oxygen. You don't want to waste feed so dissolved oxygen is kind of how much air is in the room for the fish, and as the fish get more excited or more at a higher density, they'll use more of that air up. And if you feed them and they have protein in their belly but not enough oxygen to breathe, they'll survive, but they won't be digesting as much of that protein. And so you don't want to waste the feed in that way too.
What do you feed them?
So we buy off-the-shelf pelletized feed products. In years past, many decades ago, a lot of the feed would have 70 to 80% wild fish stock in it. Nowadays, I believe that's dramatically lower.
Okay. So you buy the feed, and how often do you have to resupply the farm?
Yeah,
The
so we call it farm sites. We currently
farm
have
site.
four barges. They're unpowered. They're kind of serve as our feed vessels. They have silos that we fill with the feed. It depends on what stage the grow out is. Obviously, as the biomass number goes up and the fish are larger, we're feeding more
Oh,
and
yeah.
more. So towards the end of the grow out, you might be refilling the systems every day or two, but at the beginning, it can be once a week.
Okay. So every now and then you're refilling, and and um, how do you keep the fish safe from predators? Do you ever get like sharks come by and say, "Ooh, lunch," and want to break into the farm or something?
Yeah, some of that is the type of net we're using. In some cases, we have metal net that is predator proof, or even metal fibers integrated into the net that we
Huh.
use. But for the most part, it hasn't been an issue. Knock on wood.
Okay. Oh, that's great. That's great. What about things like hurricanes? We're sadly experiencing some severe weather as we record this here in New England, where I
Yeah,
am in the United States, and it
so it's
got me
only going to get
thinking
crazier, right?
about that. Yeah,
Um,
unfortunately, that's another subject. But yeah, what about that? Does that affect you? And do you have an advantage here with this?
it's been a pleasant surprise in Panama that the weather's
Hmm.
been pretty nice. Even when hurricanes do come through, we're pretty protected in the Gulf of Charco Azul. However, we did develop and have the technology and have demonstrated it to make our pens submersible. We operated our test pen here in Hawaii for a number of years, and it operated 90%, 95% of the time fully submersed.
Oh,
10
wow.
so the fish are down there a bit deeper. The water's a bit cooler, maybe. The current can be stronger, and this, there's a much better in terms of surviving storms or preventing theft.
I see. Is theft an issue too?
It hasn't been. We've
Okay.
really integrated with our community nicely. We're in a very rural part of Panama, and it's been really cool to see all the ways we can affect and bring new life to the area, or more life, I should say.
Yeah, that's really really nice. And so if you submerse it, how do you add feed?
So all of our feeding systems are waterborne. That's a kind of another unique
Okay.
advantage. Traditionally, the industry, especially when you're feeding salmon, the salmon don't feed at that high of a rate, and you want to spread the pellets out across as broad an area as you can. But that uses a lot of energy because moving air isn't particularly efficient. It's so compressible. So we mix our feed with water and pump it, and we can pump it either at the surface and spray it over a wide area, or underwater when the pen is submerged, and distribute it through manifolds.
So you can pump the feed underwater, so you don't have an issue with feeding. You can submerge the whole thing and take it out, and keep it safer from storms. It's great. And then at the end, how do you harvest the fish?
Yeah, we surface the pens. We take a top net off, and we use a harvest vessel. And they pull up, and we kind of use what's called a seine net to corral the fish, and then we throw a big 8 or 12-inch hose into the pen and pump them out and process. We've been scaling rapidly. We harvested 150 tons this year in Q1 and over 250 tons in Q2. So we're scaling up.
You've harvested. I was going to get to how many farms you have, or you call them not farm. You call them farm.
Farm sites or
farm sites.
Yeah,
I was going to get to that, but you've harvested 150 tons of fish
just in
year?
Q1 this year. Yeah, just in Q1, another 250.
In Q1.
Yep.
Oh my gosh! So you're really operating at a huge, I mean, to me anyway, huge scale.
Yeah. So our pens are 50 meters in diameter and 15 meters tall, and we stock them with between 250 and 350,000 fish. And harvest size
15 meters. Wait, 15 meters. Let me just get a sense in my head. 15 meters tall.
Mm-hmm.
So in, for us Americans, 45 feet or so, 45, 50 feet tall. Okay, I can kind of imagine that. And diameter?
50 meters or about 164 feet.
Yeah, in diameter. So 150 feet by 50 feet. So you're the size of like a decent sized building.
Oh yeah.
It'd
And
be like a building, like a mid-sized factory.
mhm.
That's a big structure. Okay.
Yeah, it's made from HDPE pipe, which is commonly used here in Hawaii. As plumbing, you just lay it out over the lava rock. It's incredibly
Okay.
resilient material. On the beach, we build our pens. We use heavy equipment to bend the pipes in a big ring and weld them, and put them in the water and attach the nets and drag them into place and get them hooked up, filled with fish.
Wow. So relatively straightforward materials and design to make these large structures. What's been the biggest design challenge?
I think on the one hand, scaling up very rapidly in the pandemic, going from our small test system in Hawaii that had 10,000 fish to systems that can hold hundreds of thousands of fish was definitely a challenge. And the feeding systems we use, ironing out the kinks from a process standpoint is tougher when you're in the ocean. Everything's harder in the ocean.
Sure.
The work that I've been more focused on is our underwater cameras and our own in-house solar powered systems that power them on the pen.
Okay.
And learning lessons of survivability and how to make something exist at that ocean water air boundary that's the most consistently violent on the planet.
The ocean water air boundary is violent. Yeah. And I looked at looks like your resume, like you personally, it's no surprise that you ended up there, because it sounds like you have an incredible experience base in doing things in the ocean. Is that right?
Yeah, I've been very lucky. After graduating from Georgia Tech, I've had my whole career kind of in the marine technology space. So doing some autonomous surface vessels, doing swarms of robots in Los Angeles, and a small amount of aquaculture in Los Angeles, even of a mussel farm.
Oh yeah, I saw that in your. Is the scale, for those of us who don't know the fish business so well? It sounds like you're approaching 100 tons a month in production, 250 tons in a quarter. You said, is that right?
Yep.
That would seem to me, as just a layperson here. I mean, I'm an eater of fish, but not a grower. That would seem like a lot. How does that compare to the size of other commercial fishing
Fisheries.
Companies, farms? Yeah.
In terms of commercial fisheries like salmon, I think we're still dwarfed somewhat in terms of the number of tons worldwide being produced of salmon. I don't have any numbers in terms of wild caught, but the big thing we push is, from a sustainability standpoint, wild caught is just not sustainable. We've overfished the oceans, the fish populations are crashing. So if we want fish, farming is kind of the only way left to go.
Okay. And now, are you personally, like, you've spent your career on the ocean around mussels, fish? I have to ask you, are you personally a fish person? Do you like seafood? Do you like eating fish?
Oh, absolutely. Yeah, I think that's one of the best parts of living in Hawaii, having such great access to seafood. But I miss our own fish, and when I'm in Panama, I'm always eager to get some of it in me.
Really? So this is going to be one of my questions. You really do like your fish, and it's a kampachi is the name of the species?
It's also sometimes called kumpachi with an M. It's Seriola rivoliana is the genus and species. It's a yellow-tailed amberjack is a more traditional name for it.
Okay, yellow-tailed amberjack. Okay, I can relate to that. And what does it taste like?
It's a white meat, super buttery. It's an amazing sashimi. A day or two after harvest, after letting it dry and firm up a little bit, it just melts in your mouth.
Okay. And you can cook it in all the normal ways, like.
Yeah. I think we have a lot of social media content and things on our website, all the different recipes and ways you can cook it. We have a chief executive chef, et cetera, that is always pushing all the different ways. That's the big challenge for us at this stage of the game, getting market awareness out there. If we were farming salmon, scaling up our sales would be easier, but it's we got to introduce the world to our fish.
Yeah, great time, by the way, to mention your website, because I know I saw when I looked at your website, I assume it's still there today. There was a video of all these world famous chefs, like tasting your fish and talking about it. It's a short video, but I was really impressed by the big name chefs that you had that I recommended, like Rick Bayless and people like that. That I'm like, I've heard of that name. So that was really cool. And just a little mention for our listeners, foreveroceans.com, right? That's your website.
Yep.
So foreveroceans.com, just spelled, just a nice straightforward URL. Congratulations on that, by the way, because so many URLs have, pardon? It's what?
It's tough to find them sometimes. Yeah.
It really is. And I'm pretty impressed with that. So, and just a reminder, our audience, you're listening to Masters of Engineering podcast. And my guest is Tony White. He's the Director of Innovation at Forever Oceans. And we're talking about a breakthrough way to farm fish. And again, I'm really surprised at the volume you're producing, which I just expected something way smaller than that. I thought you were going to be, just getting started, your first site. But now I realize a site is a big deal. It's not like a little thing. So, so people love the taste. Where can people go? It says on the website it's available in, I believe it's high-end restaurants and all. Other places that you could name where people could actually go taste your fish?
We've started selling it in Europe recently.
Okay.
Like you mentioned, our website does have a better idea of comprehensively all the restaurants across the U.S. that you can get the fish in.
Oh, okay. That is on the website.
There is occasionally links on our website to be able to order samples of it as well.
So you're based in Hawaii. How about the rest of the team? Where are your colleagues based?
Sure. Our corporate headquarters are on the East Coast in Maryland. We've got around 100 people in Panama, and less than that, but a good team both in Indonesia and in Brazil. And the way we're kind of structured, we have our operations team, who are the folks that are managing the fish, going offshore, doing the fish husbandry. And we have a field service team that's in country on the farm that kind of acts as the connection corridor conduit between our technology and engineering teams and the operations. And so we like to think that offers us the unique advantage of having a really short connection between the end user and the people who are making the product, as opposed to buying products from third parties.
I see. So people buy directly from you?
As
far as you...
We provide the technology like in-house is a better way maybe to phrase it.
Fair enough. But the taste is great and it's better for the environment and
Absolutely.
Sustainable.
Yeah.
Not just better for the environment, but sustainable versus non-sustainable. That we're not ruining an area of the world with waste concentration or using excess carbon or all these other, or overfishing. And you're saying pretty much all the alternatives have one of those negatives. It sounds like you're the only alternative that has none of those negatives.
We're also farming a native fish. So while escapes are definitely something you want to avoid, if we do have an escape, it's not, a critical environmental disaster.
Oh, interesting.
After the fish and go on, and it's not like farming Atlantic salmon in the Pacific kind of thing.
Oh, does that happen? That there are disasters?
It happened, and there's been, unfortunately, some really bad press around the accidents that inevitably led to.
Really?
So we're trying to really give aquaculture, a better rep.
What happens when an Atlantic salmon ends up in the Pacific? Again, this might be a dumb question for some people, but to me, I really want to know what would happen.
Not being a biologist, I would imagine that there would be some maybe competition issues, or it would hurt the chances of the Pacific salmon to continue existence.
Are you better for the environment in terms of the construction of this site? It sounds like you're using, pretty easy materials, like you emphasized in the piping and netting. Do you feel good about the material footprint?
I do. Yeah. We have really low diesel consumption per kind of kilogram of fish farmed, and the pens themselves are very robust. It's really neat to see how flexible the HDPE is on a large scale when the pens are going through heavy seas and kind of undulate with it. But no, it's a really exciting place to work because it feels like, we could make a difference if we can just keep scaling up.
Yeah. And what kind of, how big do you think it can get? Like, again, you may be the wrong person to ask, but,
Yeah, big. We hope to, be on the same scale of, a Tyson chicken company in terms of.
Really?
Yeah, that's our goal. Oh
my gosh.
Can hold, tons of fish, and we can achieve the holy grail of a worldwide, year-round, worldwide consistent supply. then yeah, it's just a matter of putting the fish on people's plates.
Yeah, that is amazing. So you have a really ambitious scope to say you're going to be like Tyson Chicken. Wow. Wow. Do you think you can have a role also in impacting world hunger? Are you going to be able to bring fish as a better, to places that can?
I can only hope. Yeah.
No, really, because it sounds like, we're coming at it from talking about, great sashimi or how I would relate to it. I'm thinking of high-end restaurants and so forth. But is there an angle here that says this is a way for people who don't have access to fish or even animal protein to get it affordably or in better quantity? Is that going to happen as a result of what you're doing?
I hope so. I mean, our early strategy has been getting the fish into high-end restaurants and things along those lines. But we definitely looked at. I know our director of sustainability has been working, with the local community and things like that. Yep.
Have you personally? One of the things I know that engineers seem to love is when they go out in the world and see their product being used. Like I love it when our software is used. I just love to see it, and we're super proud that you use our software. But have you been out? Have you seen others taste your fish, eat your fish, cook with it? Have you had personally a chance to see that, and how does that make you feel?
Oh, it's always a great feeling. Yeah, we've had some team dinners in San Diego and had our fish in a restaurant, and it's just kind of a surreal experience to say, oh, maybe this is a fish that brushed up against me a few months ago.
So your team is very distributed. And do you feel that you're able to work? Now, I know that you use Onshape to design. This podcast isn't really about Onshape per se, but can you tell us whether it's related to engineering or in general, any tricks or advice you have? Because so many of our other customers are going remote, whether they want to or because they have to. They realize their business, or if not remote, they're very distributed like you are. What advice or tools or processes do you have for remote teams?
Sure. I've been using SolidWorks since 2012. When I came here, initially we were using Autodesk products. And one of the hardest things to do is convey your design both to the end users on our operations team to review what we want to build them. And then eventually with the fabrication vendors in Panama or wherever you're at in the world across language barriers and things like that. But often the 1,000 words in a picture can be dwarfed by, a good Onshape shared link. So sometimes we'll, have our big document with all the pieces in it and pull just the things that we want to talk about or isolate the discussion to into another document, send them over a link. And without having to install any software or deal with any, private formats, it just lets them have that thing and really helps steer discussion.
What else do you use to communicate and collaborate? Anything else that you'd recommend?
Yeah, I mean, we use the Google Suite, obviously.
Okay, Google Suite.
For documents.
Well, you say obviously, but
yeah, well, I guess there's a lot of different options out there.
Well, there are a few, But
one that we've been pretty excited about lately is a Databricks platform. It lets us take all of our data. We've got a new software stack that from the beginning was optimized to be as modern and as easy to interface new pieces of data into as possible. And so being able to chuck all the data in a closet and then make some queries to easily visualize it and hunt for trends and analysis and get new insights has been a pretty neat process.
So Databricks, that's a great one, Tony, because I think that one was a little unexpected, which is why I asked the question. Is AI going to be a thing for you in more ways? You mentioned it earlier with the monitoring of fish behavior, but are you looking at any upcoming applications of AI that are going to help you?
Obviously different camera models, things along those lines, but in the kind of more personal or short-term approach, I do a lot of product development from the mechanical and electrical aspects. And usually I'll do a couple lines of code to maybe prove that I can interface this sensor to this, computer and make it happen. And then I pass it off to the software development team. Being able to use those things like ChatGPT or Google's Bard to help me more quickly develop Python code to prove the concept of the hardware that I've just developed, really lowers the barrier to entry there. What might take me a week of Googling and fiddling around to get working, I can do in an hour. So that's
so you're actually doing that today? Like,
at times.
It's okay to ask. So you're using ChatGPT and Google Bard to generate code for, to test code, not your production
Right.
final
It won't
code,
be
but
it
test
won't be
code.
production by any means, but just to show, like, either a test for making test benches, like, hey, we're going to use this servo to move a camera. Let's put it on a test bench and stress test it for a week, moving back and forth. Or, hey, I've got a new kind of sensor hooked up to this microcontroller, and I want to prove that I can send the data over this kind of radio.
Oh, that's great. Is there the possibility of locating your farm site close to where the fish is consumed? Does that become a benefit? Could you put this anywhere in the ocean, and is that a benefit?
When we do site surveys, we're looking for the right combination of depth and water quality parameters. In terms of our general strategy, I think, Panama is intended to serve North America markets. Brazil is intended to serve Europe, and our Indonesia farms are intended to serve Asia. And then we'll scale up from there as necessary. It would be amazing to be able to put farms off the coast of Hawaii or somewhere in the US in an appropriate location, but we'll just have to wait and see if that's possible someday.
Well, it sounds like you're doing something really innovative, really cool. And I really want to thank you for making it so understandable, to the way you explained it. I really can get a vision of it. And so I just want to say again, a really big thank you to my guest today on the podcast, Tony White, Director of Innovation at Forever Oceans. It's been a pleasure. I feel I could ask you questions all day. We've all learned a few tips from you that'll be interesting. And I want to say to our listeners out there, thank you for tuning in. You can learn more about Forever Oceans, Tony's company, at foreveroceans.com. Or Tony, do you have any personal or company Instagram or Twitter feed or anything that you'd want to point people to?
Yeah, I think we're active on most of the social media platforms, and there should be links on our website to those. And thank you so much for your time. It's been an honor talking with you, and having used SolidWorks and then Onshape since 2015.
Oh.
It's always been a cheerleader for it. So excited to meet you.
Oh, well, thank you so much for saying that, because really what keeps me going is always seeing the cool things people are building with the software. My business partner, John McElhaney, he calls that our emotional paycheck, so to speak. And that's it for today. See you next time on Masters of Engineering.